the concept of span, you can introduce it in the general vector space. You don't have to do it specifically in n-tuples circumstances. So that's what I do here. I start off with the general vector space, and now I fix a set of vectors, finite set of vectors. And then the span, you probably remember the definition, but that's just a reminder for you. That's a notation for the span. That's a notation for the span, and what it stands for all possible linear combinations of those fixed n vectors. It's a relatively difficult concept to grab. Even though you saw it before, you've done questions where span appeared, I highly doubt that you have a full, deep understanding of a span. It's a difficult, the null space, from this perspective, it's an easier concept to address because null space is like a solution to system of linear equations, whereas span, it's more distant. You need to do lots of examples and questions in order to understand fully span from all different angles. Oh, sorry. Now, together with span, we often give you a accompanying definition, which is called it is when we call a set spanning. For a set of for a finite set of vectors, we have one concept, linear dependence, independence. Spanning is sort of like the opposite concept. And the set is spanning if it happens that the entire vector space coincides with the span of that set.